Scott McElroy here. I want to talk about some data we've been collecting with bumpy versus smooth putting surfaces to give you some idea of what some of the data you'll be collecting means. So we want to compare a bumpy, somewhat pitted Bermuda grass putting surface coming out of the winter versus a relatively smooth creeping bent grass surface using some of our metrics of data collection. Remember that the Sphero is moving forward in the Y direction, and he moves side to side in the X direction and in a up and down motion with which we refer to as the Z direction. Okay, so we're going to compare some Z acceleration and also some velocity measurements of some of the other variables. So first, if we look at the X acceleration range, this is the maximum and minimum, total maximum and minimum values that we actually captured from these given runs. We can see that this bumpy Bermuda grass surface, we did 3 individual runs across this surface and 3 individual runs across the bent grass surface with 8 laps for 3 seconds for each lap at a 30% speed. And we got upwards for the bumpy Bermuda grass surface, the X velocity, or the side-to-side movement that's occurring. We're in the neighborhood of around 20 centimeters per second as far as the velocity is concerned, whereas the bent grass is right around 12 to 13, a much significant drop. So what the bent grass is sensing, what the Sphero is sensing from the bent grass surface is much less lateral side-to-side movement as it rolls across the surface, whereas the bumpy surface is causing the Sphero to move in a left and right direction as it rolls. And the same thing with X acceleration. This is in G's is what this is measured in, and you can see a range of around 2.7 up to about 3.6, depending on where we rolled the ball across the surface, dealing with the acceleration from side to side. And then you look at the bent grass surface, a much more stable surface in this instance. We're measuring about 2.1 to 2.2 Gs across the surface. If we look at the acceleration range, this is all components in the X, Y, and Z direction that can occur. So it's the total amount of movement that the ball can actually experience as it's rolling across the surface. We see about 3.6, 3.7, upwards close to 4.5 for 3 individual rolls of Bermuda grass, this bumpy Bermuda grass green. And we see in the neighborhood between 2 and 2.5 for the bent grass putting green. Lastly, if we look at the Z acceleration range, which is again in the up and down movement of the ball, we see from 4 to above 5 for 3 individual runs, whereas we see a much more narrow range that actually occurred for the 3 runs on bent grass. We see right around 2 to upwards to maybe about 2.2, 2.3 for the Z acceleration. This gives you an idea of what some of the putting green is actually, what Sphero is actually experiencing from the putting green, and to give you some idea of what this data means. If you look at the Z acceleration, what would an ideal putting green look like as far as one that is going to produce much less, is going to influence the surface much less? We can say that a Z acceleration of less than 2.5 Gs, a total acceleration of less than 2.3 Gs, and then an X velocity of right around less than 15 centimeters per second, and an X acceleration less than 2.2 Gs gives you some idea of what you can look for in an ideal putting green situation. We do always make the point that no single variable makes a perfect putting green. Instead, it is the balance of surface height, hardness, turf suppleness, and evenness that creates a predictable but challenging putting surface. So that gives you some idea of what to look for related to a given, comparing 2 extreme putting surfaces in this instance. And this is, of course, by no means is this anything against the Bermuda grass putting green. This is not giving a Bermuda grass putting green a fair shake. This is one that's had troubles coming out of the winter, whereas you can look at the much more uniform conditions of this bent grass surface, and that gives you some idea of what you can experience with the Sphero research app.